Welcome back, everybody. This is the 13th video in our series on building a chess engine from scratch in the Java programming language. I'm actually really excited about this video because it's the last video that's going to be introducing a new piece, and it's the most important piece in chess, which is the king. It should be a short video because the legal move calculation for a king is actually not too difficult. So we'll spend time doing that and maybe do a little bit of code cleanup. And then after this, every video from here on out should really start to get much more interesting. So if you've made it this far, thanks for sticking it out with us. And I promise that we'll really start to see some behavior and testing happening in subsequent videos. Alright, so let's go ahead and do what we normally do here, which is to create a new class, Java class, and call it the king. And let's say king extends piece. And let's address our compiler issues here. Implement our method. And create constructor matching super. Great. Okay, so let's look at the Wikipedia entry for a chess king. And so please cast your gaze here on the king on e4, and notice that the king can move in one square in every direction. Of course, there are caveats to this. Obviously, the king cannot move into a space that the enemy is attacking, and we'll cover that later and the approach that we're going to take for that. But for the legal move calculation, we're not going to have to worry about that. So really, we just need to come up with a rule that we can apply that captures this sort of these surrounding square of locations that we can move to. So let's see. We see that the -1 square from the current location, -1 tile coordinate, it seems to be a legal move. -2, 3, 4, 5, 6, 7, 8, and 9 in the minus direction, and 1 in the positive direction. 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so I think that captures it. -9, 8, 7, and 1, and then in the positive direction 1, 7, 8, and 9. And of course there will be a couple of edge cases to consider, and from what we've seen in the past with respect to our edge cases, it's probably going to be when the king is here, in one of the on one of the either the first column or the last column. So let's go ahead and jump right into it here. Okay. All right, here we go. So first, let's capture our candidate move coordinates again. So I'm going to come up over here to, let's say, the pawn, and steal its candidate's move coordinates and adjust accordingly. Come here and declare candidate move coordinates to be, as I had mentioned, -9, -8, -7, -1, 1, 7, 8, and 9, and I encourage you to confirm that again on your own. And now let's go ahead and come in here and say declare final list of legal moves is equal to new array list. Okay. And let's import that. And at the very end, we're going to say immutable list.copy of legal moves. Now it's just a matter of adding in the legal moves. So we're going to be looping over, as we always do, final int current candidate in candidate move coordinates. I think that's what I called it. Let's go look at pawn. Oh, current candidate offset. Oops. I just want to be consistent with the naming of my variables here. Current candidate offset. So we're going to loop through each one of these. And first, let's start out with, let's ignore the edge cases first and just start out with the normal case, because that should be easy and fairly consistent with what we've done in with other pieces. Let's just say declare an int out here, candidate destination coordinate, and apply and say candidate destination coordinate is equal to this dot piece position plus the current offset. And I think that's how I've done it with my other pieces. Let me just remember, did I declare that inside? I did, I declared it inside. So if we look here on the night, we actually didn't declare it outside of the for loop. Let's be consistent. So let's declare final int in here. We don't need to declare this outside of the loop. Okay, so now we have that, and we want to say if board utils dot is valid tile coordinate, candidate destination coordinate, then we want to declare candidate destination tile is equal to board.get tile of the candidate destination coordinate. Okay. And simply do the same thing that we've done with other pieces where we check if the square is occupied or not, and we can actually look at night as an example. So let's look at night. Here we did exactly the same thing. All this logic is going to be exactly the same, right? So king and knight are actually similar in that regard. Now, yeah, it's complaining because I repasted that. We don't need that. All that logic's going to be the same, right? So we're literally going through each one of these in our loop, and we're checking to see if the tile at that coordinate is occupied or not, and that will determine what kind of move we want to create. Let's do a little bit of code cleanup here. Let's see what else. So now let's focus on the edge cases. So we're going to say if some set of conditions, then we want to skip, right? And similar, I think, to the night, right? In the night's case, yep, exactly similar. So if some set of conditions, then continue. So let's actually copy. Real simple to do. Let's copy. We had from night, I copied the first column exclusion and the second column exclusion. And ours are actually going to be, the exclusions that we're going to have for a king are going to be if the king is on the first column or if it's on the 8th column. So let's just say is 8th column exclusion and column, right? And so let's see what these are going to be. The first column exclusion is actually going to be when the king is on the first column and the candidate move coordinate is either -9, -1, or 7. So let's take a look at that. If the king is on the first column and we wanted to move in, apply the -9 rule, let's see where that takes us. minus 1, 2, 3, 4, 5, 6, 7, 8, 9. Obviously not a legal move for a king that we're located on A1. But if we were on B1 and we wanted to try that out, let's see what happens. Minus 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that seems correct. So I've already worked these out. So you can either test when, you can test this rule and when it breaks down, or you can sort of take my word for it. The first column exclusion, I claim, is when the king is on the first column and the candidate destination coordinate is minus 9, minus 1, or 7. So minus, and of course future test cases will show this to be the case. Minus 9, yeah, minus 1 or 7. And the eighth column exclusion will be if the candidate offset is, let's see, I'm going to guess that if you're on the eighth column exclusion, it will break down if you go in the minus 7, 1, or 9 directions. So let's see, minus 1, 2, 3, 4, 5, 6, 7. Yep, that's not a legal move for a king that were if it were on H1. 1 obviously is not a legal move, and 9. So that would be, yeah, 9 in the positive direction would be illegal as well. And let's pick actually a square up here, H8, and apply 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so it's like the inverse when you're on the eighth column. So let's just say that it's going to be minus 7, 1, or, oops, I put two not minus signs there, 1 or 9. Right. Okay, so it looks like we have our column exclusions set up and ready for use. And all we have to do here is to include them in our legal move calculation. So if is first column exclusion, or, whoops, I'm a little fat-fingered today, or is eighth column exclusion. And all we have to do here is say this dot piece position and the candidate offset. This dot piece position, candidate offset. And let's put a new line there. Right there. Okay, so that's it. A little bit longer than what I had hoped for, but yeah, that's it for the king. Let's see, is there any other code cleanup that we can do here really quickly? You know what, I'll stop the video here. We obviously didn't come up with a method that calculates the second row or seventh row, but we will pick up in the next video and do that right away. And then start looking at how we can build our very first boards. Thank you.